GPUs have become one of the fastest growing parts of global technology spending, leading to their manufacturers becoming some of the largest companies in the world. And while GPUs aren't going anywhere anytime soon, the market for custom AI chips in the form of application-specific integrated circuits, or ASICs, is growing fast, leading to legitimate competition within the AI accelerator market. This also comes at the same time that we are seeing hundreds of billions being spent globally on AI infrastructure, from AI accelerators to data centers to networking. And now we are seeing governments come in and inflate the market even more, with an estimated contribution from these entities coming in at $1 trillion cumulatively by the end of the decade. So, with so much money floating about in this space, this leads us to the question of whether the AI GPU market can keep expanding, and if so, what does this look like? Hi everyone, sorry for interrupting, but I'm Jeremy, I'm the producer for Bloomberg Intelligence's YouTube channel, and I just want to bring you a message as these videos are brought to you by an amazing in-house team right here at Bloomberg. We really believe in bringing you the insights needed to help you understand the finance world, and to help us carry on doing that, subscribing, liking, commenting, sharing really helps us out a lot. Alright, with the admin out of the way, let's get you back to the content. Although news media is consumed with GPU sales of Nvidia and other providers, a growing proportion of the market is being taken up by ASICs. The main advantage of ASICs over the traditional GPU in AI is that they are built for a singular task. This means that they can offer the consumer superior speed and efficiency for whatever they need, in this case, AI inference. The main hurdle with these chips are the upfront costs. Despite the lower cost per chip when produced, ASIC's custom silicon programs require significant upfront expenses, between $1 to $3 billion, long execution times, and large engineer teams. This means that only a few large companies with substantial R&D and capital spending budgets, and the ability to attract top talent and bear upfront sunk costs, would be able to set up an ASICs program. To develop a deeper understanding of the cost advantages of ASICs over the more widely used GPUs, we interviewed Kunjan Sobhani, the lead analyst for the deep dive that served as the foundation for this video, to elaborate. Hi Kunjan, thank you so much for joining us today to help us go through ASICs and the AI GPU market. Why are ASICs growing, and what are they actually replacing?
Yeah, so think of ASICs as GPUs, which are really fine-tuned and optimized for very specific, stable, and unique types of workloads. For example, an internet search engine, running a video platform like YouTube, or running an ad targeting on a social media platform like Facebook. So using ASICs on these same type of or similar one type of workload again and again at a very large scale and volume, which is very important here, gives you much higher power and cost efficiencies. And this suits really well for your large hyperscalers like a Google or an Amazon or even in Meta, which by themselves have the scale of their own internal and sort of predictable workloads, again, i.e. a search engine or an e-commerce platform, that makes it very suitable to run ASICs.
However, despite the growth we are seeing in ASICs, this doesn't necessarily mean that the GPU market is going to be fully disrupted by this growing technology. GPUs are, and will remain, central to AI and machine learning, and will be critical for training the largest models due to their parallel processing capabilities and suitability for rapid iteration. Also, most organizations cannot justify the enormous financial costs, technological complexity, or substantial development risk of custom silicon. Developing bespoke ASICs for AI is a multi-year, potentially multi-billion-dollar endeavor requiring specialized talent. For the majority, potential performance gains and custom silicon do not outweigh the substantial investment and risk of obsolescence. Why do GPUs still matter as inference grows, and will ASICs just take over?
Yeah, the short answer is ASICs are not for everyone, but GPUs are. The great benefits I mentioned earlier about ASICs only work if you have a specific type of workload at a very large scale or volume, and with a very high predictability, which, like I mentioned, only a handful of hyperscalers today have to justify the need for ASICs. Secondly, it requires billions of dollars of upfront R&D, many years of R&D, more than a few hundred semiconductor engineers, and the need to deploy millions of units of ASICs to make the economics advantageous versus using a GPU. And finally, when we think of broad-based enterprise-level AI development, you need flexibility and programmability, as AI workload use cases are changing every 6 months now. And you also need a robust and open software ecosystem, which GPUs from the likes of an NVIDIA offer over ASICs.
When it comes to the groups making global AI infrastructure investment, they predominantly come from the same small group of hyperscalers. In total, AI-related capital expenditures are on track to reach $1 trillion annually, with about $600 billion coming from cloud service providers and the rest from sovereign projects and enterprise customers. BI has projected that the capital spending from the leading hyperscalers, Meta, Oracle, Google, Amazon, CoreWeave, and Microsoft, will reach $539 billion in 2026. This has been driven by an urgency within these companies, which has been emphasized in recent earnings calls. We asked Kunjan why this might be. So my next question here is, what is really driving AI hyperscaler spending now?
Yeah, one of the largest drivers of incremental new capex from hyperscalers is coming from inference growth. The training capex is still robust and growing in some areas, but inference is really the tailwind of growth going forward. And the reason for that is these hyperscale customers are now seeing tangible monetization benefits, both from a revenue generation perspective and also from a cost and efficiencies perspective for their own internal businesses. Second, a bunch of these hyperscalers are also cloud service providers to external customers, and they are seeing significant rise in demand and monetization potential from selling cloud services on top of these GPUs and ASICs to these external customers. Which, by the way, on the external customer side, a lot of this demand is driven by the rise in deployment of agentic AI and AI services, as well as a rising AI adoption across enterprises of all shapes and sizes and all industries. Finally, there continues to be a significant demand also coming from this group, which we call the frontier model development capex, as well as inference needs from these model creators. Because think of the ChatGPTs of the world, the Geminis, the Anthropics of the world. These are now also seeing a rise in their ability to monetize from their model investments.
It's not just hyperscalers, however, that are fueling the growing demand for AI infrastructure. Governments have emerged as a secondary source of demand, with sovereign AI projects now being funded due to economic competitiveness, national security, and public sector modernization. Of a $1 trillion annual projected global AI-related capital expenditure, 20 to 40% of the market is projected to be from sovereign and non-cloud service providers. Specifically, the United Arab Emirates and Saudi Arabia have committed tens of billions of dollars towards national AI infrastructure. The UAE is on track to import more than 500,000 NVIDIA GPUs annually through 2027, and Saudi-backed Humane aims to deploy several 100,000 chips over 5 years as part of a $10 billion data center expansion. So, with the growth in expected capex in the next decade or so, the question naturally turns to how companies are positioned in the market. Well, as AI scales, the market seems to be shifting away from standalone components and towards full-stack systems. AI accelerators are increasingly sold as part of integrated platforms that combine silicon with high bandwidth memory, networking, and advanced cooling. To be specific, NVIDIA's evolution from selling individual GPUs to providing fully integrated AI service systems marks a pivotal shift in its business model and mirrors this broader industry trend. Their chip architectures deliver complete AI-optimized service systems. By integrating computing, networking, and memory into full-stack solutions, it's deepening its market penetration, enhancing monetization per system, and positioning itself as the dominant force in AI infrastructure. This systems-level approach increases complexity for suppliers, but it also raises the value per deployment. By delivering complete solutions rather than individual chips, providers can command higher average selling prices and take on a larger role in how customers design and operate their AI infrastructure. For buyers, these integrated systems reduce deployment risk and shorten time to scale, which matters as AI moves from experimentation into core production workloads. So what defines competitive advantage in AI hardware now?
Yeah, the first and foremost differentiation today is the vendor's ability to design and develop or outperform at a system server level, no longer at a chip level. Chip players that we talk about in this report, especially NVIDIA, are no longer just selling chips on a card, but are selling entire systems, in some cases with their own designed stack of chips, not a single GPU, but stack of chips, coupled with high bandwidth memory, coupled with their own networking gear running on their own protocol, their own cooling protocols, and more. So the supplier who can win at a system level is going to get most of the share. A clear example here is why NVIDIA continues to lead, especially is when they moved from their Hopper architecture, where they had the lead on a GPU at a chip level, to now a Blackwell architecture level, where what really helped them maintain the lead was not just the GPU chip advancement, but really was their networking and system design innovations. You can no longer just be a good chip design semiconductor supplier in this space. You need to innovate across software, networking, memory, cooling, and now going forward on chiplets and silicon photonics if you want to stay ahead of the curve.